Geometry, Chapter 1, Section 1, the building blocks of geometry. So the first concept is a point. A point is the most basic building block of geometry. It has no size, it only has location. You represent a point with a dot and you name it with a capital letter. So you can see here we've got a point P, and its name is a capital P. I can make any point I want, so I'll make a point N, and its name is a capital N. Next, we have a line. A line is a straight, continuous arrangement of infinitely many points. It has infinite length, but not thickness. It extends forever in two directions. You name a line by using the names of any 2 points on the line, with a line above it. So here's our diagram. This is our line. You got points A and B here. Now note the arrows on both ends, indicating that's going forever in both directions. Its name is both the points A and B with a line above it. And notice the arrows above it. Now I can add an additional point on this line. Let's say this is point C. And so I can now name this using C. So AC, or I could also do BC. And also, I could reverse the letters. I could do BA, or CA, or CB. It doesn't really matter, as long as I've got 2 points with a line drawn above it. That indicates a line. Now also, a line can be named by a single lowercase letter in italics. So this M is the name of this line. So I could call it AB, but I also call it just with the italics lowercase letter m. The line segment. A line segment is a straight, continuous arrangement of finite number of points, not infinite, with 1 point at each end. You name a line segment by using the names of 2 endpoints of the line, with a line, no arrows above it. Line segment will be measured in length as it has a fixed length. Now, we actually can physically take a ruler and determine the length of this segment. So you can see here is our line segment, AB. I can, again, put additional points on here if I want. But note I would not use D and C to name it. I name it by the endpoints, AB. And then for its measurement, there's 2 ways I can indicate it. The measure of AB with the line above it. So I just put the M in front of the AB. Or I can just say AB with no line above it. Both of those mean the same thing. In general, we will be indicating all of our measurements indicated like that. That's how we will be indicating measurement in general. Array is a straight, continuous arrangement of infinitely many points in a single direction from a starting point. So it's like a line, but it's only like a half of it. It's an infinite length in one direction, but not thickness. You name an array by using the name of the endpoint and any other 1 point on the line. So I could name this array here AB or AC, and you can see the arrows going in one direction. And you cannot measure the length of array as one side goes on forever. So I can't physically measure this. Collinear. If points are on the same line, then they are collinear. If points are not on the same line, then they are non-collinear. So here, ABD are collinear. EBC are collinear. ABE are non-collinear because they're not on the same line. Midpoint. If a point is marked on a line segment that is perfectly in between the two endpoints, that point is called the midpoint. The midpoint bisects the line segment, or it divides the line segment into two congruent segments. So here we've got this line, segment AB. The midpoint is C. It cut the line segment AB in half. It bisected it. These markers here indicate that those two segments are congruent. In other words, this segment and this segment are equal in length. And so you can see here, the measure of AC is congruent, is equal to the measure of CB. AC is equal to CB, or AC is congruent to CB. You'll notice here, I didn't put the little line above these. There should be a line here and a line here. A plane is a flat two-dimensional surface that extends infinitely along its length and width. So think about a piece of paper that just goes on forever. Plane is usually represented as a parallelogram, and it's named either by three non-collinear points on the plane or by a single italics capital letter. So this is our plane here. You can see it's a parallelogram shape. You've got a number of points on there, A, B, C, and D. This is not a point. That is the name of the plane. It's a capital letter, and it's in italics, so the name is P. You also could name it by ABC or ADC. Now note, I don't name it ABD because the 3 points are collinear. I have to use 3 non-collinear points. In other words, 3 points cannot be on the same line. So I have to name it with 3 points that are not on the same line, as we did here, ABC or ADC, those 3 points. I have to use 3 non-collinear points. Coplanar, if points are on the same plane, they are coplanar. Just like collinear, points are on the same line. Collinear, same plane, coplanar. If points are not on the same plane, they are non-coplanar. So here we've got A, B, C, and E are coplanar. D is not on the plane. It's as if there was a line going through the plane. A is on the line, D is on the line, but D, this line is going through the plane, so it's only intersecting the plane at point A. So D is not on this plane A, B, C, E. So my question here is ACD coplanar? Well, if you remember, the definition of a plane was any 3 non-collinear points. Well, ACD are non-collinear, so yes, ACD are coplanar. In other words, they make up their own plane. They make up their own plane. So there's a second plane here that wasn't drawn, that I just drew. It's this plane of ACD is intersecting the original plane that's drawn. So while D was not on the original plane, we created a new plane, ACD. Let's do some algebra review. So let's talk about slope. Remember, slope is your rise over run, which is your change in y over your change in x. Rise over run, change in y over change in x. So let's find the slope of this line here. So change in y, how far do I go down? We go down 6. How far do I go over? We go over 7. So the slope is negative 6 over 7. More coordinate plane. We're going to look at a midpoint. Remember, the midpoint is the exact middle between A and B. I'm going to just approximate. It's approximately right about there. And that would make these two segments congruent. But let's actually look at how we can do this algebraically. The midpoint is the average of your x coordinates and y coordinates. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's look at the coordinates of these. A is at negative 3, 4. B is at 4, 2, negative 2. So x1, this is x1, y1, x2, y2. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that's 1 divided by 2, 2 divided by 2. So we've got 0.51. And you can see that's approximately where I put it. I was a little bit off in my just throwing it up there, but it's right here. That's our midpoint. So that's the end of Chapter 1, Section 1 notes.